Howdy everybody in YouTube land. So what we have in front of us today is a lot of Macintosh crap that I purchased. Shipping was kind of high, so it was 125 bucks to get all of this crap. Now, seems kind of expensive, right? But it's actually not bad because we got out of this lot, we got an LC2 board, which appears to be in pretty decent condition, no bombs or anything like that. We got a Macintosh IIciX board, which again appears to be in relatively decent condition with the exception of capacitor damage, but that's not unsurprising. And it contains RAM, right? We got a 2CI cache card out of the deal. We got a Macintosh Classic motherboard, which is in good condition. I got two auto inject floppy drives, one for an LC, they're both 2CX LC2 floppy drives. We got a battery bombed Macintosh Classic motherboard, which I'll likely part out, but hey, we got good parts. And then we got some, random speaker. This is not included, by the way. And then we got a complete 2CI, which it needs a little bit of love and retro brighting and stuff like that, but it's not a big deal. Complete with minus the hard drive, but it's got the bracket. Everything's in here. It's even got RAM in here. It's got the cache card. It's missing some of that, but who cares about that? It needs some capacitor work on it. Power supply probably needs caps, but other than that, that's a pretty good machine. It's complete. There's no battery bomb on this machine either, as far as I understand. So for 125 bucks, I don't think I did bad. And actually, a lot of this is going to end up getting passed on to someone who needs parts. Like, this case is a little weird. It's not wanting to go back in. Yeah, it's being... Anyways, like for example, I don't need those two floppy drives. I can sell them back off. And this Macintosh IIciX board I don't need. I could sell it back off. Same thing with this LC2 board. But anyways, so the point of this video is I want to take a look at this. So here we have a battery bombed Macintosh IIci board. Now I could just part this board out, of course, and not have to worry about it and just throw it in my part stash. Or I could at least attempt to fix it and see if we can actually make this thing, or like a resurrection. We can make this a resurrection video, right? So bare minimum effort required to get this board to post, and then just do away with it, right? So I think that's what I want to do here. So I want to see how bad this board actually is. And upon first glance, it looks terrible, but it actually doesn't look terrible. So it's bombed out, of course, but the ROM doesn't look like it was affected too much. And it doesn't look like any of the major chips have seen any sort of permanent damage that would prevent this thing from ever working again. Even if we beta reloaded board, all the critical components besides the RTC, which might be shared with like the SC30 or something, I don't know, and that's been reverse engineered. So we could potentially, build a reloaded board, a 2CI reloaded board, but I don't know if that's ever been done yet, the design anyways. This could be a good candidate to reverse engineer because it's screwed anyways. Anyways, so upon first glance, we have that. We've got the typical capacitor damage, everywhere, leaking all over the place. Up here too. But overall it's not bad. And it looks like we've got some mud dauber, wasp, poop everywhere. So this thing was left in a barn, literally. Yeah, that's the only explanation I have for that. There's some of this crap on the bottom. Maybe it was someone trying to clean the board. I don't know. But we've definitely got some destroyed traces that likely are not going to be any good. And it kind of runs all the way up through the top here and around to the data bus. Actually, it's going to the SCSI bus, I think. A lot of it's going to the SCSI and floppy. Yeah, because it's going both to the floppy and SCSI connector. So the external floppy and SCSI may not work, but that doesn't really matter, really, because Again, it's a resurrection. I'm not gonna put this in a machine. I don't need a board. Yeah, it needs love. There's some corrosion down here where these vias and all that stuff are. So it's definitely seen better days, but overall, it's actually not too bad. And it would probably chime if I remove this ROM jumper and put like a one of those Rominator cards or something in there. It would probably try to run, but I'm not sure. I think this is the memory controller, because if we look, there's 74 F258s don't exist on this board like you see on the 2CX and the SE30 and all of that, because I think it's all wrapped up inside this chip here. So this is doing the ROM select, the memory timing and all of that. They just offloaded it into this chip. So that's all intertwined into this. So it'll probably give you death chimes if it gives you any chimes at all. Right now it probably won't even power up. But I bet if I recap the minimum and then put a ROM sim in here, I bet I'll get minimum death chimes. But with another ROM sim anyways. But you never know. We might be able to get this thing working, resurrect it. We might not. But I figured why not. So, yeah. I figured I might as well just check this RAM out here real quick and see what we got going on. At least these have the metal tabs. I might scavenge these sockets if I part this board out. Ugh, maybe not. It's a bit of corrosion. Oh, yeah. It's bad, but it's not that bad. I can clean that up. I might be able to deoxit that, honestly. It ain't gonna work as it is. It's just been too exposed to corrosive contaminants. And not just battery either. There's been other things going on here. So, yeah, you can kind of see the rust there. So, yeah, this one might be done, but we'll see. We'll see. It might not be down and out yet. So that appears to be, it says 4 megabytes. So I don't know if these are actually 4 meg sims or if it's a 4 meg set. I don't know. But anything's possible, I suppose. I don't know. I have to actually calculate it out. But I see 3 chips, so it's definitely parity memory. This is probably for a PC. That one's not bad. What is this one? 1 meg. So these are 1 meg sims. So there's 4 megs here, and there's 16 megs here, which makes sense, I think, because just like the SE30 and the 2CX and all of that, you kind of have to have the large amount of memory in bank B with the small amount of memory in bank A. Because of the way the frame buffer is set up. I don't remember. God, that's scratching the crap out of my fingernails. But it's fine. It's so strange to me. This one's not even the same manufacturer. MIC2 RAM. I don't... What? Can I order a MIC2 RAM? Welcome to MIC-RAM. Can I order a MIC2 RAM? No. So there's that. These are all the same. Nope. So I got 3 of these that are the same, and one that's not like the others, which makes sense because this is parity memory. I'm pretty sure 1, 2, 3, 4, 5, 6, 7. No, maybe not. It's just more. I see what they did there. And 1 meg. That's 1 meg, 1 meg, 1 meg. There's 4 megabytes of RAM here, and there's 16 megabytes of RAM here. So, if anything, I got RAM. These 30-pin sims are getting hard to find, and they're getting expensive. So, yeah, I have RAM now. But it's weird. These 4 sockets are okay, the ones that are closer to the battery, except for these. So there's been other things going on here. It's like the battery just kind of dripped on it a little. I don't know. But anyways, let's peel that off. So I think I'm going to have to throw caps in here temporarily to try to even see if this thing's going to chime or do anything at all. But I definitely got to get detailed photos before I start scrubbing this board, because I can't scrub the board too hard because these resistors are going to pop right off, because they're just, I guarantee the solder joints are just barely hanging on. So okay, I think we need to clean this up. We got to clean this up. But before I do, I need to get detailed photos. But you can just see the corrosion in various spots, like up here, just kind of randomly scattered about this board. But hey, I've been able to fix worse boards. You've seen them in prior videos. There's one board I did that you've never seen on a video, which I should have done a video of it, but I didn't. I got the board out to dry right now. It's all washed up in vinegar, saturated and cleaned up, and it's ready for drying. So that while that's going on, I wanted to do some work with the RAM. So what I did was I took my fiberglass pen right here and I just kind of went after the contacts, which is killing into the plating a bit, but the plating was corroded off anyways. So I did that as best as I could. Then I went right behind that with some of my Deoxit D5 sprayed into this rag to kind of just clean it up a little bit after I did it with the pen. So I'm hoping it works. But they cleaned up really well, actually. I think they did anyways. They're nice and clean now. So I have those, and I went around and did the same thing to this one. So it's all been fiberglass sanded and cleaned up as well. So I'm hoping this RAM is good. So we're going to set that off to the side. And now it's a matter of waiting for the board to dry. And I need to fire up this computer so I can get to the schematics and stuff. They didn't come out too bad. So if we look at this, it's kind of bad, but not really. I mean, I've been scratching at it a little bit. It's going to need some scrubbing to really get that off. There's only so much time I want to put into it, but other than that, it didn't come out too bad. No, I dried it up a little. Yeah, there's a little bit of corrosion here. I'm gonna have to double check all of that, which that goes to the internal floppy connector, so that's not gonna work. Yeah, so okay, so we have this. I didn't lose any resistors or anything, but yeah, so okay. Just gotta clean it all up and patch things. Boy, it shouldn't be too bad, I don't think. We'll give it a try. Not a big deal. It's actually not that bad. There's a couple. It comes up through here and goes up. That goes to the data bus for sure. So I got a patch there, because it's coming out of here, which is a memory controller. It goes around. Let's see. There. Here. Goes around. Goes up to there. So those will need patches. I can jumper wires from here to wherever they gotta go. Not worried about that. Yeah. What'll be a miracle is if these ROMs are any good. Yeah. Okay. Well, the real-time clock's not gonna work, but it'll run without it. Not properly, but it'll run without it. Okay, so let's get all this cleaned up. Alright, so I've been going through this board bit by bit, and one thing I'm learning is you see these little green patches here and here. Like there's a couple there. There's a metric ton of them over here, for example. One there, one there, one there. Just these little light green spots. Every single one of those is open, because I've been scratching them away. Like this one's open. You can see where I scratched that one away. It's open. This one's almost open. So I went over here. This one's open. Let's see if I can get the right light angle. This one's open. This one's fine. That one's open. That one's open. This one's open. That one's fine, but it's almost open. So every single one of these that has a light spot is open. See, there's a couple here. Those are open. So there's one here that's open. So every single one of these, all of this appears to be fine, but this is all dark copper, not light copper. See, that's how you can tell. So when the corrosion is light, like this one here, and not dark, it's open. So that one is open for sure. And then I have this one, which is also open. And then I'd scratch some of this away down here, and this one's open. And it's actually not open until you get to, I want to say it was like right in this territory here is where it was open. So that's open. So I scratched this one off. It's open right there. There's going to be one here that's open. So all of those are open. So there are hundreds of those spots. Like there's one here. This one's going to be open. So, and it's going to be open right there too. So it's the battery, not just the battery acid, but the fumes of just eating this board alive. So, oh yeah, you can really see it here. Yeah, all those light patches are open copper lines. So that doesn't include everything on the top. So I cleared all this out. All of this is open, which makes sense because that's where the battery was. So I was just hoping maybe a few here were open and I can just patch them across, but no. There are far, far more. And all these are address lines that run back to the CPU, every single one of them. So on the top copper, I don't really see much. My only possibility is I don't have the original case that this came out of. So it's possible that the entire shield had rotten away and it was outgassing, and that's what was eating all of this up, because it's not on the top side, it's on the bottom side. So unfortunately, there's going to be, it's primarily centered over here though. There's going to be, oh, there's one there. Open. You can see it. So unfortunately, there's probably going to need, and here it is in a better light. It's probably going to need at least 100 patch wires, if not more. Oh god, there's even one right there. You can see it. It's open. So it's one of those things. It's like I really wanted to resurrect this thing, but at the same time, I also know you have to know when to call it quits. You have to know when to call it quits. And I think the threshold of this particular project, we've crossed it. So I think at this point, I'm not going to repair this board or even attempt to resurrect it, because there's just way too many traces that need repair. So I would be here for days running patch wires, trying to figure all of these out. So unfortunately, I believe I'm at the end of the road with this particular board, unfortunately. However, there are quite a few semiconductors I can actually save off of this board that I can use on other projects like Reloaded boards. We've got a swim chip, we've got a SCSI chip, we've got a CPU we could use on like an LC or something. We've got an FPU I can use in a SE30 Reloaded project, but we're all good. We've got enough parts here I can reuse it with other projects. So unfortunately, I think that is the end of the road for this particular board. But we have another 2CI that we need to look at. Well, since that board was a massive failure, and because it's on the same topic of what this one is, I figured I might as well just run them both together as one video. So here is the other 2CI, which I don't think there's a problem here. I don't think this one is bombed. At least, I don't think so. If it is, my life just got incredibly more fun. Okay, let's see. What do we have in here? So this one is, well, that's kind of screwed. But I think it's because it's got to come out anyways. So I might as well just leave it like that. Yeah, this circuit board looks much better. So this has a cache card in it, which I don't know if that's a PDS slot. I think it is. I think it is cache memory. It's just SRAM. And this is the controller. Not exactly sure how that works with a 030, but yeah, that's bad. It's gonna have to get cleaned up and replaced. So we have that. We know we got to get out. The other thing too is we need to pull this power supply out, and to do that, I need both hands. All right, power supply's out of the way, and it's not incredibly dirty. It's not clean, but I wouldn't expect it to be. So, is this the same one I just worked on the 2CX? I'm not sure. There's no date code. Date code 89. So, may just be before the leaky poo era as far as the through holes are concerned. But the logic board for sure is definitely gross. So, I gotta take that out. Okay. Well, that's fun. That's 16,000 feet long. Okay. Floppy disk drive cable's got to come undone because, yeah. Well, it still has the battery in it. Whew, well, gotta diffuse that situation. Because, yeah, that's all kinds of bad. Yeah, it didn't leak, but it's going bye-bye. Okay. I need to take you out. Because this board's going to get a nice clean. Just like before. Let's see. How do you Quarko twinculate out of there? Oh, there we go. Just like that. Not much to it. Dusty. Get that out. Then that leaves the motherboard, which I think just slides forward. Kind of. Nope. I think you are in the way. Nope. I like toolless, semi-toolless cases. Oh, God. That one's really bad. I might have to replace that chip. Well, I know where I can get parts. I can just get it from that board. So, yeah, that one's bad. I'm going to have to clean that mess up. Let's see, what else do we have? How bad's the rest of it? Ugh. Gross. Yeah, the cap goo is worse on this board, but hey, at least we're not bombed. And all the traces actually look nice. And not like they've been through World War II. Okay, I gotta get this thing out. I need both hands to do it. Board is out, so now we can take a better look at that. Dust bunnies. We're gonna need to clean that guy out. Probably just blow it outside. It needs retro bright anyways. But just set that out of the way for right now. Which reminds me to take a look at this. Let's see how bad is that one. Oh God. Just like the 2CX. That's a mess. Oy. Alright, well. First things first. Take a look at this motherboard. I want to see how bad the damage is on this chip. Ooh, yeah. She's going to need replaced. That is horrible. At least I know where to get one. So you need replaced. All three of those appear to be intact with no leakage. But the surface mount ones are not so fortunate. Oh, God. That one's also bad. Alright. But no bombs. Let's look on the back side. Let's see how much cleaner this one is. Oh, yeah. That is far better than the other board. Weird. Everything is so nice and shiny. Not dull and dingy. So this board might be a runner. Well, once I get the caps changed, at least. But I've been shocked before. You can have the cleanest of boards actually be bad. I run into it. Nasty. Yeah. Gross. Okay. Well, let's see what kind of RAM we have installed. Looks like there's only 4 megs in the front. What's in the rear? 16. So it's the same configuration as the other one. 4 megs in the front, 16 in the rear. So what's that, 20 megs total? Alright, well, we need to get the RAM out. We need to wash it. Alright, so I took the floppy drive out, and just like the 2CX, this thing is a complete dumpster. Just cram-packed full of dust. And I think it makes sense because of the design. So you gotta think, the floppy drive and the hard drive is up front, and then the power supply sits like right here. So, and it sucks the air through the front of the case out the back, so the floppy hole is going to be the least path of resistance. So this brings in all the dirt. Disgusting. Alright, so I'm going to have to go take this outside and blow it out. And currently the motherboard is drying. So by the time I get this thing all lubricated and cleaned up, that motherboard should be ready to go. And then I still have to get inside here and pull out the reefas. That's better. Now, I've noticed the drive is fully collapsed like a disc is inserted, and if I try to remove it, it won't, it's stuck. So, we're going to have to do some repair with the mechanism, which is not that big of a deal because it's got to come undone anyways to get relubricated. So, something is stuck, but it's not a big deal. We just got to remove the eject motor, check the eject gear, remove the carriage assembly, lubricate everything up, and, you know, the typical spiel when it comes to Macintosh floppy drives. Now, the old eject gear crumbled as expected, so, but new eject gear, lubricated with a little bit of oil, and we're ready to go. So we can just take this guy and start putting it back together. Now, I still got to lubricate the mechanism, so that's now out of the way, completely done. Oh, so now I gotta clean up all this crap. And it was gummy. I'm not surprised. And there we go. We're all lubricated. So it should take a disc now, and it's fully ejected. So the only questionable situation right now, which varies from drive to drive, is if that reed switch that's inside the eject mechanism needs cleaned or not. Because sometimes what will happen is that switch will go bad or become problematic, and it'll stop like halfway through the eject, where instead of going ree and kicking it out, it'll go ree and then stop. And that's why you got to clean those switches. So hopefully that doesn't need to be done. Alright, so now that the board's been washed and dried, we now can have a clearer picture of what we need to attack here. So we have the 74 ALS 240, which is completely gone, so that's going to have to be replaced. And then those pads are going to have to get cleaned up, and those traces are going to have to be tested. But also over here, the Bourne's network that's in the floppy drive port, we got a similar situation going on there. So I got to pull that and likely replace it as well. And up here doesn't look terrible, but it doesn't look good. So yeah, that's where we are. So I'm going to have to pull some of these parts off, use lots of flux, and see how bad this actually is. Now, the sound chips, they should really be pulled and cleaned, because they're, like, terrible. So I might do that. I don't know yet. But the good news is At least I think, I have to look and see, but I think this parts board, everything's clear. Oh, yeah, there we go. So that looks good. I can reuse those. Down there is kind of questionable, but it's not nearly as bad as the other one, so I can probably reuse you. And the apple chips are much cleaner, so I might reuse you as well. So, okay, good. So I can actually use parts off of this board. So that's a win. At least get the one that's in better condition going. Well, subjectively better condition anyway. So, all right. Okay. Let's get the hot air tool out and start going to town on this thing. It's cleaning up pretty good, but there's a few problems. So, I removed that chip, the pad's all cleaned up, and everything's okay over here except for these two in the middle. These two are open from each other, but it's also open from here to this trace. Luckily, it's all right there, so that's easy to patch. Now, the Floppy Bourne's filter network is, there's barely a pad left there, and the other pad's completely gone. So, there's nothing left on that one, and both traces are open, so I have to run patch wires between these two, so that's going to be interesting. Now, the two soft start chips, I removed them so I can clean the pads because they were just completely trashed. So I took some acetone here in a cup and tried to clean up these chips as best as I could along with the sanding block here. So I'm hoping these chips are still good. They may or may not be, I don't know. But they're cleaned up as best as I possibly can. The same thing with the audio chip here. Cleaned them all up as best as I could. So I'm going to remount those guys. But none of the other traces are open as far as I can tell. Everything else cleaned up pretty good. This was nasty as hell, but it cleaned up. So, alright. Not too bad. Not too bad at all. This chip I didn't have to remove. I just fluxed it and it's good to go. And there we go. Those two have been remounted, so almost like nothing ever happened to it. And those are the original chips I pulled off, by the way. So I got the filter network and that one just kind of like soaking in here and clearing all the crap off of it. And I want to mount those back on here. And I got to make a couple patch wires for this one. Unfortunately, but it is what it is. But I'd rather make a patch wire here and here versus 50 of them like the other boards. So that one's back in place. And it's all good now. I blobbed the solder over on these two pins and then kind of bumped it over there. So that fixes all the broken connections. So that's the only two pins that were out. The rest of them are okay. So now I've got to get you put back in there, which is going to be fun. But here's what it is. Got the filter network reinstalled and the two patch wires are in place. They're in there. So there we go. At least that one was simple. So okay, that's done. That's done. The only thing left to do now is to throw caps on it and cross my fingers and hope like hell it actually works. Now, I got to get caps for the motherboard, but I decided to pull the cache card out, and sure enough, it had two 22 microfarad 25 volt caps that were completely shot. So I removed this one. Now I removed this one and I found a via right here that has gone open. So that was breaking the connection from here up to here. So patch that up. So that's now working. I don't see anything else that's open at the moment, as far as I can tell. So this should work, but it's not like I don't have another one of these. So even if it doesn't work, I've got another one. So, and I'm pretty sure the cache would probably speed this machine up quite a bit. So, alright, we'll keep plugging along. And a few hours later, actually several hours later, it is recapped. So I got the axials replaced. They were probably okay, but I kind of like killed this one with heat. Which one is it? Not that one. There it is. See, so I'm just heck with it. So I went ahead and replaced them. These are getting very hard to find now. These are ones I got from Radio Shack back in 2014 when they were going out of business. And then this one I had on hand from probably similar time period. So I went ahead and changed them all. All the surface mount caps are in there. I did not have any tin microfarad electrolytics, so I just went ahead and put ceramics in there. Whether it works or not, I don't know. This is part of the startup circuitry, so if it won't work, you'll know because it won't turn on, right? So, okay. I think that's it for the main board. Now, I'd love to just hurry up and try this board, but I can't do that because I need to get into that power supply and see what we have going on because I don't know what the status of the refas and stuff are in there. So I got to get that out before I can do anything else. And that's it for that. The card is done, the cash card, and I got the patch done here, which all it needed was a blob, and I got the patch done over here. So as long as there's no more faults with this board, wishful thinking, everything should just work fine. But I do need to get the RAM put in there, so I need to get the right. So this is a 4 meg, 4 meg, 4 meg, 4 meg, and these are all 1 meg. So if I remember correctly, the 1 meg has got to go in bank A, so that makes sense. And so bank A. Every time it's kind of like freaks me out because of the yeah, I'm probably not going to put the whole thing in there just yet. I just want to make sure that it works. You know what I could do? I could grab the power supply out of my 2X that I just recapped and just leave it that way, but you know what, the heck with it. I'll just put that whole thing in there, and I'm pretty sure if I were, let's say if I wanted to run 64 megs in here, you can't just put, what I have to do is I'd have to put the 64 megs here and then put like the mega, or leave this 1 megabyte in here and make it work. Because I think it's got the same problem that the SC30 has, but I could be wrong. So, okay, all good. Now we'll just go ahead and get the case cleaned up because that still needs done. Okay, no corrosion in there, and we need to get in that power supply. So let's pop that apart next. Taking this power supply apart is really fiddly. It's a pain in the ass because you got to get that out, and then you got to fish this connection out here and try to finagle it all out of the can. But I got it out, and the good news is there's no X-Class refas in here, unlike the 2CX. But there is some Y-Class refas in here, but I got those. I can just go ahead and change those out real quick. But more importantly, to nobody's surprise, now the 2CX power supply wasn't doing it, but this 2CI power supply is pissing everywhere. So gross. Oh, look at that. Yeah, it's funny how it just leaks through the solder. I mean, look at that. That's so bad. So bad. Alright, well, I guess we're going to have to get those caps out and clean that mess up, unfortunately. But it is what it is, you know? Just the way it rolls sometimes. Alright, so here's where we are. I pulled all the caps off of it, which they're puking everywhere, so no surprise there. I got to clean that up. So I pulled the transformer and a couple of the coils out of the way so I can get to it. I got the refas removed. I'm going to go ahead and put some new ones of those in there. Y caps. But perhaps there's a more important problem I noticed. And it might be normal. I don't know. But look at this. R322. It's just burnt. It burnt the board. So, I don't know if this cap failed. I checked. It doesn't seem to be shorted. None of the transistors or anything are bad, so I'm not sure why that is, but that resistor still reads exactly 120 ohms. So, if that resistor were bad, you wouldn't think it'd read exactly 120 ohms. It would be infinite or some oddball value, but no, that's reading exactly 120 ohms. Don't know if it's part of this IC302, which is probably a TL431 if I were to hazard a guess. I don't feel like bending it up and creating more fatigue to check, but it probably is. So I'm inclined to leave it. I'll likely just reflow the solder, but the more important issue now is cleaning all this nastiness up so I can replace the capacitors, because they're completely gonzo. They're shot. And I think it's just because it's a low ESR caps. These low ESR caps just love to leak. Like this one didn't leak because it's not a low ESR cap, I don't think. But let's see, what series are these? Well, that one puked everywhere. So this is a PF series. Yeah, it's a known bad series. Yeah, so. Okay, let's clean it up and get it fixed, because no way it was going to work. At least not properly. So it's a good thing I tore this thing apart. And that is the model number of the power supply. AA15830. So, clean this guy up and keep on trucking. And there we go. So, they're all done with the exception of these two, which hardly ever go bad. I mean, there's a first time for everything, but I'm going to leave them for now. This one I ran out of, so I left it for now. It's also a standard one, and it's not in low ESR. It's the low ESR ones that started leaking like crazy, but they've all been replaced along with the two there and those. The board's been reinstalled, so everything, the coils, all that stuff's been done. The reef has been done. So I think at this point, I should go ahead and put it together and hope like hell it works. Alright, power supply's put back together. I just kind of got it propped in here right now. I don't know if that's going to work. I got a speaker hooked up. Well, here we goes nothing. Withdrawed current. Hey, it's running, but I got no chime. No chime though, but it is running. It's on. So why don't we have chime? Now remember, I reused the original audio chips, so it's entirely possible that I'm not even getting a pop out of the speaker. Alright, so let me grab some headphones and see what it does with headphones. Alright, before I go and get headphones, let me get this power supply propped up where it's a little more straight instead of angled down. Now we're getting something. Not exactly what I'm looking for, but well, hey, we got something. Not the result I was hoping for, but that's just how it goes sometimes. But we got something. That means the CPU's running, everything's running, it just can't see the RAM. Why can't it see the RAM? Alright, that's enough fooling around. I'm going to go grab a ROM sim and see if that makes any difference. Because it might just be... Yeah, because I've heard cases where these ROMs have gone bad, so I'm going to bypass that. I doubt that's the issue, but you never know. So I'm going to grab that, and then if that doesn't do anything, then we're going to try to clean up the RAM and all of that fun stuff. So there's something definitely going on here, but it's better than what I had before. Alright, so a couple things here. I grabbed out my troubleshooting bag. Put a blue SCSI in there just to see if I can see any drive activity. I also grabbed my adapter to, to set the sense lines, just to make sure this thing isn't picky about not having a monitor plugged in. So let's try it again. Nope, nothing. Alright, so now what we're going to do is we're going to stick a ROM sim in here. So we have to disable the internal ROM. So we're going to use this GG Labs Max Sim. We'll throw it in there. And then try it again. Interesting. Very interesting. We're getting SCSI activity, yeah. See? Whether it's going to boot from it or not, I don't know, but yeah, that's interesting to me. So maybe we have a bad ROM. I'm starting to notice. I got a friend of mine that has one that the ROMs don't work on, so maybe we have a bad ROM. Here's something strange. Okay. Last time I saw that happen is when I saw a transformer short, like in an 8100 power supply. That's not good. Yeah, explain that one. Alright, so I swapped the RAM out just to make sure I have known good RAM. So we'll put it back onto the original ROM. I have the floppy emulator hooked up now, assuming this power supply stays on this time. I think I might know what's going on with that power supply because I did some research, and apparently a friend of mine alerted me that these are notorious for one of the diodes or transistors to go bad in the standby circuit and it'll oscillate. And I'm thinking that's what's going bad in this one, and it's right next to that big resistor that got hot. So that explains everything. Anyway, so as long as it stays on, I should get death chimes even with this different RAM. And now I'm not. Now it's not doing anything. Alright, so let me move this jumper over, which will turn it back, will turn the external ROM back on. Now it's running. I want to mount the Lido boot disk, and I want to see if it actually tries to read the disk or anything here, because it wasn't booting from the blue SCSI, so it may not actually be working at all still. I don't have a monitor plugged in, so I don't know for certain. And it's not doing anything. Oh, there it goes. Yep, it is. It's working. So this board is booting up. This board is running off of that ROM sim. So that there you go. That tells you right now that these chips are bad. Or there's a trace open on one of them, which I doubt that because those traces run through to the RAM. So if there was a trace open here, it wouldn't read the RAM. And since we're booting, that means it's able to work with this first megabyte of RAM. So I know, yeah, so the chip is bad. I guarantee it, the chips are bad. So, okay, let me turn the power off now because it seems to be stable. Let's take this Maxim back out of here because I think this is a 2SI ROM. Move the ROM select back over. There we go. It just didn't like having that sim in there. Yeah, see? Bad ROM. That's what it is. So let me turn the power back off. Let's grab another ROM sim, which there's another one in here, but I don't know if it's any good. This one came from who knows where. I don't even know what ROM is programmed on. See, I don't have a programmer for these. So it's not like I can just go and take a stock 2CI ROM and just throw it in here because it's not going to work because I don't have a... Anyway, so move this jumper off. Let's see what this ROM sim does. It runs. Mount the Lido boot disk. Yeah, it runs. So runs with that one. I don't know what ROM they're using on this. Apparently it's okay with that hardware. Yeah, see, it's working. No problems. Alright, so yeah, we've got a bad ROM. So I'm going to have to just leave one of these sims in here. So it is what it is. But first off, I got to tear this thing back apart and replace those transistors and do a diode mod. So what we're going to do is we're going to pull the ROMs and we're going to try to read them and to make sure they're actually good. For now, I need mark those. That way I know what they are. Okay, so alright, so let's go ahead and get these ROMs out of here. I want to put sockets in them play. I think I have DIP32 sockets. I'm not sure. If not, I'll have to order them. I'll have to order chips anyways if they're bad. But yeah, I'm just going to go ahead and pull these out and test them in my programmer and compare it against the known good ROM dump and see if it is correct. We'll figure out which chip is defective really quickly. Alright, so I got the ROMs out of the board. So these particular chips are compatible with the SST39SF010 JADEC standard, so that's what we're going to go with. So we're going to do that. We're going to, so device read, or no, command read. Yeah, we're just going to read it anyways. So that is it's not going to be very legible because of it's a 32-bit system. So we're going to save this one. We're going to put this into the folder ROM dumps. We're going to make this one Mac IIci. And this one's going to be, what is it? LL. Save. Do that one. And then we're going to do this one here. Read. Save it. This one's going to be ML. ML. And then this is MH. Save this one as MH. And then we're going to take this one and we're going to save it as HH, which, if it'll fit in there, it's not really wanting to go in there. Not well. Alright. Man, read. Save this one as HH. And there we go. We'll take that and we will compare it against a known good one. We're going to figure out where the differences are, because something is up here. Alright, so I downloaded the 2CI ROM file, the real one, and I use this Easy Bin tool, which will allow you to split it into 4. So what I did was I took the good ROM, split it into 4, and I started using Hex Workshop and I started comparing it file by file by file until I got to LL. Everything matched 100% until I get to this one. And then guess what? There's one that's off. And if we look at it, the dump from the chip, this chip right here, LL, the dump from this chip has 07. The original file has 27. The 1 byte is blowing the whole thing up. 1 byte. And if we look, it's bit 5. So we lost a bit in this chip. So that is why it's not working. So we're going to have to get another ROM chip. And I have the battery bombed board I can pull it from. So I pulled the LL chip off of the bombed board. I got the bad one over here. So I pulled that one from the bombed board and matched 100%. So there we go. That's how we're going to solve this problem. But the other next issue is I want to put sockets in here, but I don't have 32 pin sockets, so I'm gonna have to use these. Not exactly what I had in mind, but it'll work. I'll just have to trim them down. New sockets, and the other ROM is in there now. The old one's out here currently. So here we go. Does it work or will it not? Bingo! It works. Bad ROM chip. Wow. Alright, so to fix the weird power cycling issues this thing's doing, which seems to be very random in nature, and I know why. So I did a quick little research on it, and a friend of mine pointed this out to me, and apparently I posted on a thread sometime back in 2014 when this was going on, and I don't remember it, but now I do. So basically, the Aztec power supply has a problem with the way the circuit's designed on some of these. So it goes into details here. You can read this for yourself if you want, but I'm going to skim through it. So it says the solution to the problem is to replace D15 by 2 silicon diodes. And well, here's a picture that he sent, and this is the mod. Okay, now what I want to address is right here. If you remember earlier in the video, this resistor was like totally cooked. I mean, even on this one, look at the board. Well, look what's next to that. These transistors are affected by the heat of that resistor. So I'm wondering, since the trickle issue was kind of an early on failure, I'm wondering the late stage power supply failure is caused by that, the heat baking, saturating, and killing those transistors. I could be wrong, but I've seen noisy Japanese transistors before, so chances are they're probably bad. So I'm going to see what I got on hand. I'm probably going to change these 2 transistors and do this mod to this particular power supply, and hopefully that fixes the weird hiccuping and stuff that's going on. So we'll give it a shot. Alright, so I got the power supply back apart now, and I'm looking at the circuit, and you can see how baked that board is from that resistor from getting hot. And the capacitor, this is part of the oscillator for the standby regulator, and it's like glued right to it. So this cap has been baked out. Now, it's a film cap. It shouldn't have any problems, but I mean, it's what, a 30-something year old power supply? 32, 33 years old? Hell, I don't even know. It's old enough to where anything's possible. So I think, according to what I'm doing over here, I'm actually looking at the 2 transistors. So the PNP transistor is a 5401, which is this guy here. The one behind it is a 2SC 1213. Now, I don't know if I have a data sheet for that, but it's just a 35 volt half amp, which the MPSA 06 will just sub in that one. Now, the MPSA 06 has got a different pinout. Base is in the middle. Whereas on a 1213, I'm pretty sure the base is on the right hand or the left hand side here. So, but I could be wrong. I got to double check that. So always pay attention when you're substituting transistors, which ones go in there. Now, I don't know if I can use the 06 there. I think I can, because it's a 35 volt and this is an 80 volt half amp transistor, where this one shows it's a half amp transistor. So I should be able to use that there. Now, the 5401 is a 150 volt transistor at 300 milliamps here, somewhere between, I might as well say about half amp. But the 56 is only good for 80 volts at a half amp. So that's an issue. I got to see if I can put another one in there. I don't know if I can sub that in there, because I likely need the 150 volts because of the, it's probably dealing with the rectified DC current off the rectifier. So, yeah, and I think that resistor actually powers that circuit. So, alright, I'm going to go through my parts stash and see what I have on hand, because I'm going to replace these 2 transistors, and I'm going to do the diode mod as it indicates in this particular sheet. But also, it says it might be considered to change C34 to 39 nanofarad, which I got to see if I have that on hand. So this is a 39 nano, or this is not a 39 nanofarad originally. This one is a 3.3 nanofarad, which is a big difference. So this is 3.3 nanofarad, and it wants me to go to a 39 nanofarad, which is quite a bit of a difference there. So, but I will look in my stash and see what I have on hand, and perform the mods and hope it works. Alright, so I got transistor number 1 out. This is this 2SC 1213. This one goes base, collector, emitter from the right. So it's going to go base, collector, emitter. So base is there, collector, and then emitter. Now, the MPSA 06, which is what I'm going to use in its place, the MPSA 06 goes emitter, base, collector. So that means it goes emitter. So emitter's going to have to go there, base is there, then collector's there. So yeah, it's going to not fit in exactly the same way, but it should work. Now, this one, the 56 won't go in its place because of the voltage requirements. So I do have these. I forget what I bought these for, but I got a pair of them. It's much bigger than what I need, so I'm gonna do the data sheet for that, and I'm hoping this doesn't alter the characteristics too much, because it does say in this manual that the function of D15 is critical to compensate for voltage junction gap. So this is going to alter that. So it'll definitely be an interesting situation if it works. So I got to pull that up. See, STX 93003. So STX 93003. Okay, let's see. High voltage fast switching PNP power transistor. That's kind of what I expected. This goes up to 1 amp. Let's see, base current 1.5 amps. Ooh, yeah, that's not gonna work. No, 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 no. No, this one's not going to work because my base current is way too high. Actually, no. Half amp, 1.5 amp peak. Half amp, 1.5, see, peak, 100 milliamps. Peak is 100 milliamps. So, yeah, that's a huge difference. So this thing needs too much base current. So I might have to leave that alone, unfortunately. I don't have one that will go in there. I'll have to look through my stash and see what I got, but that won't work, so that's out. But this one will work, at least for the one in the back. And then I gotta go through and my bag of random assorted diodes. I think I got something in here. I think these will work. These are general purpose. I think I got some general purpose diodes in there that'll work. Unfortunately, it's yet another thing to go on a parts order. So I do not have the transistor for this one, so I'm going to hope it's good, although it doesn't look very good, especially on the top here, because I don't have another one to go in there. So I want to replace the one in the back, though, because I do have that one, and I have my 2 diodes, and I have the replacement capacitor. Now, I found a discrepancy, unfortunately. So according to this sheet, it says the original cap is supposed to be 33 nanofarad. Well, if I read this, which, let me push it over, this is a 3.3 nanofarad cap. So, yeah, so I'm just going to put a 3.3 back in there and hope like hell it works. And hopefully this thing is stable. And there we go. So the rear transistor has been replaced. It's kind of in there funky because I had to match the pinouts. The diode, the double diode upgrade's been done, and a new capacitor's been tossed in because it was leaning up against this guy and I didn't trust it anymore. So they're probably fine, but you know, my concern is going to be this transistor in front. But hey, If it works, great. If not, well, we tried. And remember, we still have that bad resistor over here that's not reading bad, so I don't know what's going on with this thing. Just lots of hours, I guess. So, alright, let's get this thing put back together and we'll try it again. And we'll just add these to our collection of accumulating bad parts. Alright, here we go. Power supply's back together. Is it going to work, or is it going to go up in a big giant ball of flames? I don't know. Let's see. It's on. Smelling for smoke. I don't see any. Yay, it works. I can smell the cap juice from the fan motor. It's working with the modded power supply. So there we go. New transistor, new diode, 2 new diodes, and a capacitor. Seems to be working fine. And you know another thing interesting? I don't hear that weird hissing, screaming, tickling noise inside there either anymore, like I was hearing before. I mean, the fan's noisy, I can hear that, but I was hearing like digital hashing noise coming from this power supply. Well, that went away ever since I replaced those. So maybe that had a lot to do with it. Alright, so now that we have the power supply fixed and we have the ROM replaced because the ROM was a problem, this board appears to be fully working now. I went ahead and moved over the 4 megabyte SIMs from the battery bombed board over to this one. So I got the original 4 megs over here in bank A, and then I got 4 more megs here, so this should give me 32 megabytes of RAM. So it appears to chime with it. Now, I think without further ado, we need to start putting this machine back together and start getting it back in the case. And finally doing a final test with the monitor and all of that, because why not? There's our final tally of bad parts on the Macintosh IIci. All of the reefa caps and the leaky electrolytics all over there, the eaten chips, and then the bad ROM, and then little pieces to fix the power supply. So, alright, I'm going to clear all this mess up and then get the IIci set up on the bench so we can do a final test and make sure the floppy drive and all that stuff is working. And there we go, it's booting. It's all put back together. I got the cache card in there. I don't know if that card is being detected or not. I don't know how you would tell, but I put a hard drive in there. I actually took the hard drive out of the 2CX and then, because this one had the bracket, so I moved it over to the bracket and put the drive in there. So this is actually booting up the OS install that I had on the 2CX. Now, I'm surprised it's not throwing an error saying it's not for this Macintosh model because I didn't do a universal install, so. But hey, it's working now, at least, so good enough for me. That avoids me having to go in and redo literally everything. So I think we're okay now. Now, I don't know if I actually have a, I don't think I have a tool in here that will do. No. Actually, maybe I do. System info. There we go. Let's try that. This will tell me everything I need to know. Yep. 68030 at 25 megahertz. Gate info. Doesn't say if it's got cache memory or anything. I can't really tell. Disk cache 32K. Yeah, seems to be working. Well, I mean, it seems to be working, but Well, let's run some benchmarks. Alright, we'll let this guy run. This is going to take a while. Aw, it's 0.1% lower than what it should be. Anyways, it's right in line with the 2CI because, well, that's what this is a 2CI. So it appears everything's working as far as I can tell. Video performance is the same. Well, almost. There's some differences here. Disk, I didn't test. FPU, didn't test it. So it should be, well, anyways, you get the point. Everything appears to be working, so we got one more thing we need to do. Actually, two more things. I got to check the floppy drive, and I got to check, there's something I want to do with the cards, too. Alright, so the next thing I want to do is I'm going to kill all this for a minute. Is I want to test the floppy drive, so let's just stick this random whatever in there and see if we can format it. It's making some noises like it's working. Oh, wait. Interesting. Makes me wonder if it's got bad sectors. But that's a good way to exercise the stepper motor. Okay. Yeah, it's literally writing to the disk. Huh. That is a new one for me, I want to say. Well, I'm just going to wait for this to be over. So I'll be back here in a minute. Wow, that took a lot longer than it should have. And that's exactly what it is. It's a Windows XP startup disk. So let's just erase it. Get rid of this and make it a Macintosh disk. Macintosh 1.4 meg, erase. At least I know with erasing it's going to demagnetize the heads, which it already did that anyways by trying to write to the disk. But the fact that it initially read the disk gives me hopes that the drive is perfectly fine. Well, we haven't tried to eject yet. Sorry for the seizure salad, but I don't know how to lock the frame rate to the camera. Hey, no bad sectors. So now it should be a Macintosh formatted disk. Let's just throw something on it, because why not? Alright, so I just threw an alias on there. Nothing special. Alright, so let's eject the disk and make sure it actually ejects it. It sounds like ass, but it ejected it. Now it's an aftermarket gear, so I'm not surprised. So it's working. Alright, so the next thing I want to do is, I think this freshly restored 2CI needs something a little special. So why don't we shove this nice, new in the box MacCon Ethernet into this machine, because I think it deserves it. Don't you? Alright, so we're going to go ahead and shut her down and get that done. Alright, so the power supply seems to be stable now that I did that mod and did the transistor swapping and stuff, so it's not going crazy like it was before. Alright, so let's get this guy open. I'm not exactly sure a good spot to open it. One thing I noticed is this shrink wrap is actually shrinking still with time. Alright, I need both hands. Alright, got it out of the box. So here we go. First time opening the physical box. I haven't opened it yet. Oh, the smell this thing is emanating is kind of interesting. Oops. I don't think I did that right. No. Oh, this thing smells so bad. I don't know how to explain it. Let's see. I have the installation guide here. Very thin paper. It's almost like sheet, like a, I don't know. Mail us your registration for lifetime warranty. I wonder if they'd still honor that. Maybe. Here's a manual. Ooh, a nice floppy disk. Oh, this thing smells so bad. I can't help it. Oh, we got a manual. Don't need that manual. And there is the EtherTalk installer with SNMP. Brand new in the box. No electrolytics to replace. Thank the Lord on that one. Oh man, this smells so bad. I've had this card for I don't know how many years now. But I never had a machine to use it in. I just kind of just had it. Now I finally found an excuse to open the box of this particular card. Because now I have a machine to put it in. Looks like it's a DP3902 standard any 2000 compatible chip with the new bus adapter. Okay. Alright, so let's go get that thing installed. Looks like I got some... Oh, that Ethernet cable looks like a phone cable. That's kind of strange to me. Alright. I don't need it, so I'm just going to put it back in the box. Don't need any of this stuff. So that's what we're going to do. We're just going to put it back together. Alright. Let's take one of our 3 free new bus slots. And just put this card in it. Here we go. We have now installed the card. So let me get all this cleaned up and we'll move right along. Alright, so now we're booted up. We have our card in there and I got my Wi-Fi bridge connected at the moment. One thing I noticed about this disc is it's actually an 800K disc. So that's kind of cool. Let's put her in there and then see if we can do an install of the software. Installer. I think this is an Ethernet driver. Now, I believe the Apple Ethernet driver supports this card natively, but I could be wrong. But I don't have that handy at the moment, so we're just going to run this. Aww. Well. No, I only want to do... Whoa! Oh, yeah! Wow! Wow! Whoa! I got smoke! That ain't good. Yeah. That card's no good. Yikes. Yeah, this room smells now. So I took this card out and this one's really hot. So from what I can tell, this little module here, this DPS, come on, focus, DPS 0502B failed. And you can see why, because if you look very carefully, there's a crack in the epoxy and you can kind of see a little bit of solder blob there. Well, that's a tantalum. So there's 2 tantalum capacitors and there's an inductor in between that are in there, and that tantalum capacitor died. That's exactly what happened. Tantalum capacitor shorted in that regulator. So now we need to find out what that actually does. So from what I can tell, it's going to these two vias there, which run over to that transistor, but it also runs over to that diode. Goes into this IC. So that's a regulator for this tin-based 2 jack, which I don't need. So I'm going to suck that thing off of there and get rid of it, because that's not important. Brand new card right out of the box. Fried. So we're going to have to remove that, and I'm going to have to heat up that soldering gun and remove it. Oh, it's so bad. Alright. I took the DC-DC converter module off, and we're still linked. You can see it. So, apparently this is for the tin-based 2 coax network, which I'm not going to use anyway, so we're just going to leave it alone. Alright, so let's try this again, shall we? God almighty. Alright, so customize, because it won't install. Let's just do new button. No. Sante, new bus. Ethernet driver. That's all we need is the Ethernet driver. That should work at least, because all open transport and all the other stuff's already installed. Removing outdated files. Interesting. Alright. Restart. Alright, so let's see. Whoa, I can... Alright, we're done with that. Alright, let's see if the network control panel has the Ether Talk now. La 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 la. Ooh. No, you know what? It's going to be Apple Talk. God, this thing's so... The mouse is like hyper fast. I gotta turn that down. It's optical anyways. Ethernet. Yay. It's not going to see anything because we're bridged over a Wi-Fi network, so we have to use EtherTalk IP or Apple Talk IP to get to the server. But let's see, TCP IP. Let's see if it works, because it may or may not. I don't know. Let's turn it on. Ethernet will be supplied by DHCP server. Save. Here comes the fun part. Nope, nothing in there. No, I don't have anything. Let's see. I might need to install a newer Apple Talk, cause yeah, or nope, I already have it installed. Will it find it? Or is this card actually dead because of that? Yeah, it shouldn't be taking that long. Nope, that's a problem. Yeah, nope. I think she's dead, Jim. I'm going to have to do some more playing around with this. So I completely reinstalled the system software, and I didn't use the driver disk this time. I'm using the Apple drivers, and it's still doing the same thing. So I think that card's dead. That's unfortunate, because that's the only one that I had. And it was new in the box. But that card is dead. Now, it's funny because I used the Asante Ethernet test software, and it passes the loopback test. So something's up with that. I'm not entirely certain what yet. I should have paid attention to this earlier, but I didn't. So I got the network card, the link. Now this is on my file server. So apparently, I should have looked closer, but on this router, there's a light that's supposed to be lit up. Well, it wasn't lit up. Now, when I tried to plug in the Ethernet cable, I was just getting flashing green light. It's because it wouldn't negotiate. So what I did was, I used an AUI adapter, and now it's linked. It works fine. It's working fine over Chin-Base 5 or whatever that is, StickNet. But unfortunately, because the way Apple designed this case, you can't plug this thing into it. I had to take the Had to take the thing apart so I can get it to plug in there. But that works. So that means that this chip that I removed, which I looked it up, this is a 5 volt to 9 volt boost converter. So this 9 volt boost converter is responsible for this somewhere, I think. I've got an itching suspicion that's what it is. But it's working on the standard AUI, which passes directly to this chip anyways. So there you go, because I think this chip here and this chip is the same. They're exactly the same. So this is doing the job of this one. So if this isn't getting power, well, it's not going to work, right? So there we go. There we go. So it's working now. I'm on the file server, so I can actually copy over the file that I want to use, because I'm looking for the network time protocol file. So in here somewhere, there it is. Network time. Copy. Because I want to get that working, because the clock doesn't set on these. Bring in here, goodbye, system folder, let's see. Network time. Time.nist.gov. And then time zone, Eastern Standard Daylight. Then set time. See if it works. It should. Yep, there it is. August 19th, 2023, 4:32 p.m. So there we go. Now we have a clock. TCP/IP is working. So, oh, dang it, man. So I gotta fix that card. It seems like I'm always fixing something. It's killing me. The card was brand new. Really? Oh well. That's just how the ball rolls sometimes. Sometimes the balls have flat sides, in this case. But hey, you know. Actually, I'm taking a closer look at this. The DP83902 has a twisted pair transceiver input outputs on chip. So the twisted pair connection does not go through this 83C92. The 83C92 is definitely dedicated to this thicknet only. So it won't work. It's not working with that installed. Or, I mean, missing. It won't link. So I don't know if it's not linking because of this voltage is missing, or if it's not linking because something else is going on. So what I need to do is I need to look at this data sheet and see if there is a VCC pin that's needed for more than just 5 volts. So here we go. VCC 5 volt, 5 volt, 5 volt, 5 volt, 5 volt. Okay. So yeah, this is a 5 volt only chip. So that's not what it is. See, there it is, the twisted pair. This is the chip. And there's the filters and chokes and all of that, which is this guy right here. Or actually, it's right here. Never mind. Yeah, it's right there. Okay, that means that it's just not able to negotiate with that switch. It just won't negotiate. Maybe that's what it is. It's entirely possible it won't negotiate with that Linksys E1200. This does, but that, you know, I don't know, that's weird. Well, short of trying a 10 base hub, which I don't have, I can't get this card to negotiate. I tried a WRT54G, which I know works with these kind of cards. Won't work. Does the same thing. So I'm thinking this DC converter only runs this thicknet. It doesn't run anything else. So I'm thinking somehow this 83902 got damaged when this went bad and smoked. I'm not sure. So that's the end of the road for this card. I could probably get a new chip from China or something and then replace it. But at this point, that's about as far as I can take this 2CI. That's a whole separate issue altogether. So I think everything else appears to be working fine. The machine's working fine. I got sound. The SCSI works. The external floppy port works. It all works. So at this point, I'm going to call it one for this video. So that is now a fully restored Macintosh IIci. So if you have a comment, please feel free to leave one. And don't forget to hit this like and subscribe and all that fun stuff. And thank you for watching. Until next time.